got cut off there. We worked out this area was, what did we get? 2.104. The integral gave us a negative, but it gave us a negative because we have the two things in the wrong order. We did that so that we wouldn't have to separately plot a separate function. So our answer is 2.104 plus 4.78, or 0.478. 2 carry a 1, 8, 5, 2.582 is that area. Cool. Suppose I know the derivative of this function capital H, and I know h of 3 is 5, and look, they even filled that in a chart. Can I use the derivative to say stuff about the function? Well, yes. The point is that h of 5, for example, minus h of 3, is the integral from 3 to 5 of its derivative. If you know the rate of change, then integrating it is the thing that gives you the total change. So I want to be able to integrate the function x squared over a bunch of regions. I'm going to graph it. Let's go to a standard window. Let's calculate the integral from 3 to 5. It is 32 2/3. So h of 5 minus h of 3 is a gap of 32 2/3. I need to increase this by 32 2/3. I'm going to get 37 2/3. What's the gap from 3 to 4? That's going to be the integral. Calculate the integral from 3 to 4. It's 12 1/3. So I need to add 5 onto that, and I'll land at 17 1/3. To work out values left of 3, I'm going to be subtracting the integral. I'm going to ask my calculator, hey, what's the integral from 2 to 3? What's the integral from 2 to 3? It's 6 1/3. So I need to subtract 6 1/3. 5 minus 6 1/3 will be negative 1 1/3. I need to calculate the integral from 1 to 3. Calculate the integral from 1 to 3. I get 8 2/3. I need to subtract 8 2/3. 5 minus 8 2/3 is negative 3 2/3. And then what's the integral from 5 to 1? Negative 1. To do that, I need, what's the integral from negative 1? Right, not that. Calculate the integral from negative 1 to 3. It's 9 1/3. I need to subtract off 9 1/3. 5 minus 9 1/3 will be negative 4 1/3. As I'm filling in the chart, I could use this to piggyback to here, and I could use this to piggyback to here. Like as you add more values, you don't have to go from 3 every step, but that's sort of the easiest. Like it's not much easier to type in a number. I guess the next one is a place where it's easier to piggyback. I want to know, this is the same deal where I use the integral to know how much do I need to change the value by, but this time I have to work out the integral by myself. So let's say to go from 0 to negative 1, I need to subtract off the integral from negative 1 to 0 of that function. So what's this integral? It's this amount. It's going to be negative because we're below the x-axis. I need to work out what's this area. The area is, this is a trapezoid. There's a formula for a trapezoid. I guess maybe it's easier if I cut it up into a rectangle and a triangle. This rectangle is 1/2 by 1 is an area of 1/2. This triangle is half of that area, so it's 1/4. So this integral is negative 3/4. So that's saying from negative 1 to 0, it decreased by 3/4. So I need it to be at 2 3/4. If I'm going to decrease by 3/4 and end up at 2. What's going on from -2 to 1? This one's easier. It's just a rectangle whose area is 1/4. It's the same as this triangle. It's a triangle, not a rectangle. I know what a triangle is, guys. Guys, I know what a triangle is. I'm really good at triangles versus rectangles. It's a decrease of 1/4 over this gap, so it must have been at 3 before it decreased by 1/4 to land at -1. What's going on between 0 and 1? This is a tricky one. There's 2 triangles here. If I figure out what's going on, I can work out the equation of the line as a brute force way at this, but this is at 2/3. This is a gap of 1/3. This is a gap of 2/3. This positive triangle has an area of, oh geez, this is going to be rough. It's 1/3 by, what's the height, is 1/2. So the area is 1/2 base times height is 1/6 is the area of the little triangle. What's the area of the big triangle? Is an area of 2/3, or a length of 2/3. The height is 1. So this area is 1/2 times base times height is 1/6. Wait, they can't both be 1/6. Oh, 2 times 3 times 2 is not 6. I screwed this one up. 2 times 3 times 2 is 12. So I have a positive area of 1/12. I have a negative area of 1/6. The total area is a 1/12 minus a 1/6 is -1/12. So from 0 to 1, the function decreases by 1/12. From 2 to decrease by 1/12, it's going to be 1 and 11/12. That'll be 23/12. What's going on between 0 and 2? This one's going to be rough also. I have a base of 1 and a height of 1/2 on this rectangle, so 1 by 1/2 makes an rectangle of area 1/2. This triangle has a base of 1 and a height of, we're going from 1/2 to 2, so that's 1.5. So 1/2 of a 1 by 1.5 triangle is 1/2 times base times height is, half of 1.5 is 3/4. So the total integral from 1 to 2 is 1/2, and 3/4 is 1 1/4. That's how much this increases by. What is 20? We started at 2, we subtracted a 1/12. We added 1/2 and 3/4 is 1 1/4. Give me that as a fraction. 19/6. What's going on out here? We have a rect. And I picked some gross functions. Sorry, guys. I did not realize these shapes were going to be as annoying as they are. One way at this is to figure out what's the average height of the function. I'm going to imagine taking that triangle and lopping it over here and turning this trapezoid into a rectangle. This has a height of 2. This has a height of 1.5. So the height of the rectangle that matches it has a height of 1.75. So this area, if I move that over here, will be the same as the area of this rectangle, which has a base of 1 and a height of 1.75. So I need to increase by 1.75. What do I get if I add 1.75 to that? It's 4.9. Give me that as a fraction. It's 59/12. What's going on from 3 to 4? Let's do the same, average the rectangle, turn the trapezoid into a rectangle by cutting this off and moving it there. This was a height of 1.5, this was a height of 1, so the average height is 1.25. Base of 1, height of 1.25, I need to add 1.25. That'll give me 37/6. And then, what's this one? Oh, this is the exact same shape as that, but